things I want you to make sure that you're comfortable with topic 8 is the conceptual understanding of these things that we've been talking about. So these statistical measurements that we're programming, or basically programming them all. And then also being able to use any of the intrinsic functions associated with those. And I included sort in there as well, which we're going to use in this topic actually, but they're all kind of categorized under the statistical functions data analysis category. The only algorithm for this topic, and I know I've said this, but I'm saying it again, is a sum function. That's the only algorithm. So I showed you how the sum function basically works. You can choose to write that in your own function and then call it, or you can just keep writing different sum functions. I think you'll need about 5 of them if you write them on your own. Okay, I have a treat for you. I hope it works, because I tried to test out the audio. Sound isn't working. That's bad. She's gonna rap, but she's not working. Oh, maybe it was my computer. It's working. Actually, I'm having a really hard time not dancing right now. Let's go. So, this is a challenge. Starting with the mean, this is what you're going to do. Sum up all the numbers from 1 to n and divide it by n include 2. Sweat. I'd like to be on that left row. Question that we hold for you. If we were to do MATLAB 2 next position of median in the middle of the view. I can also find the load for the lowest legal value. If I was to do in MATLAB, I'd find the measurement. I'd find the measurement. Tell me the road or tell me the road. Do you have median or your standard deviation for variation? That was That's it. Didn't she do great? That was a student from my previous school at Fairfield. I used to have the students do video projects, and so that was her video project. Most people did like really boring like PowerPoints where they were just talking, and I was like, oh my god, I can't watch this anymore. And then Jen did that, and I was like, this is amazing. So you don't have to do those, but pretty fun, right? Okay. All right, so I'll post that so you can watch it later. I know it's going to be stuck in your head anyway. I feel like that was a bad idea to show you. Like, just you. I know I'm going to regret that. Yes. Okay. All right, so we're doing interpolation in the next topic. So keep in mind that the goal of all of these topics that we're doing is to be able to write the algorithm. So there are intrinsic functions to do all of this stuff, and you're going to use those in your pre-lab to figure out how those work so you have something to compare to. But the lab is going to be to program linear interpolation yourself. And it's not just linear interpolation, but it's a window algorithm, which is a little bit different. So let's just talk a little bit about, can you guys see this okay? Let's talk about what interpolation is. So interpolation is, you've definitely seen it before, but I kind of come at all of these topics from a modeling perspective, or sort of like a research perspective of when you would use these types of tools as an engineer or a researcher. So interpolation we often use in order to predict points of your data that weren't originally collected. And oftentimes we are looking to interpolate one set of data onto a different set of data. And that's what we're going to be doing in this topic. And so the idea of interpolation is really simple. You just take two neighboring points and you find their average basically between them. But the algorithm is much more complicated than just that equation basically. And so we're going to actually write out the pseudocode for this today. And so what interpolation looks like is you have a bunch of data that was collected. So let's say this is like time, and this is some measurement that you collected. And maybe you collected it at every 2 seconds or something, but you wanted to know the value. So if this is 1, 2, 3, 4, so 2, 4, 6, 8. Let's say you wanted to know the value at 9 and you only had values collected at 8 and 10. Interpolation would allow you to predict what that data would be if it falls between the data that you collected. And so there's a couple things that are important about interpolation. It doesn't really make sense to interpolate unless the data that was originally collected is assumed to be exact or accurate data that can then be used to predict something in between. So, for example, sometimes if you're collecting data in time, it wouldn't make sense to interpolate between times. But if there's an obvious trend in the data, then it would make sense to interpolate it. And so it's typically used to obtain an approximate value between data points. Now I took this topic out, the topic of curve fitting. I've done it every year for a long time. I took it out. This is the first time I took it out this semester. And you will do this in 303. We just did linear curve fitting in this class, and you do higher order curve fitting in 303. But I just wanted to point out the difference between curve fitting and interpolation because people often confuse the two, and they're very different things. So curve fitting is when you collect data. So let's say you have all these data points, and you fit a trend line to the data. So the trend line is not exact values. It's just showing you a pattern of what the data is doing. And you wouldn't want to use curve fitting in an example like this, or sorry, interpolation in an example like this because the data has a lot of noise in it. And so if you were trying to predict a value that you didn't have a value for, you would first want to fit a curve and then approximate that way. The algorithms are very different, but I'm more talking conceptually that these two things are very different. So just keep that in mind. Okay, so let me go through linear interpolation, specifically the formula that we're going to use. So the idea is you want to assume that you're given 2 points, just to start, just to think about it. And you're looking to find an approximate y value for any x where x is bounded by the 2 points, basically. So any location between the 2 points that you're given. So what that looks like is you'll have 1 point, x1, y1, and then you'll have another point, x2, y2. And let's say we're trying to find some point in between. So linear interpolation would say that you would draw a straight line between the 2 points,
and let's say we wanted to find it at x star right here, you would just go up and the y value would be on the linear line. So the formula is just to create a linear line between the 2 points and then plug in the x star value, or you can create 2 similar triangles where you have your little triangle here and then the bigger triangle, and then you know that they have the same angles, so the ratio of their sides would have to be the same. So that's going to be, you can go either way to get the formula, but if we just draw out the sides, this side here is going to be y2 minus y1, and then this side here is going to be x2 minus x1. And then you can do the same here. This one is x star minus x1, and then this one is y star minus y1. So using similar triangles, we can just say that those 2 ratios should be the same. And so you would get y star minus y1 over x star minus x1 equals y2 minus y1 over x2 minus x1. So that relates the 2 points that you know with the x star that you're trying to find and the y star that you're trying to calculate or trying to predict. So you can solve for y star. And so you're putting basically all of your knowns on the right-hand side and your only unknown on the left-hand side. So we're going to be writing a function that uses this formula to basically predict any value of x star between any other 2 x values, x1 and x2. So this part is fairly straightforward to program this in, but the difficult part is to write the algorithm that locates x1, x2, y1, y2, that bracket, the x star. So that's what the algorithm that you're going to write is going to be. So keep this up on top. So let me just explain a little bit more about what that means. So my example is that, let's say you collected data at every 2-second interval. But you need the data at every 1-second interval. Sounds stupid. I mean, it is, but like, it's just an example. We actually use interpolation all the time in modeling because we often have grid data on the wrong locations in the grid, and so we interpolate to get them on the right locations. So the way to think about it is that you have data like this. So these are your data points, the circles, or the dots. So that was what was collected. But you want them in between, at every location in between. So it's not just that you want to find a particular x star for a particular 2 points, but you want to write an algorithm that's able to take every x star value and automatically locate its bracketing point and then set its y star value. So in lab 9, I actually don't even remember what the data is. Anyone recall lab 9? Looked at it? Play the game? I know some of you are already done with it. Oh, solar energy. Yeah, so you have solar data that's collected every hour. So you have solar data that was collected every hour, and you're going to linear interpolate it to every minute, basically. So I would recommend that when you're doing that the first thing you do is you actually do it with the intrinsic function so you can see what it should look like, and then work on your algorithm. So let's talk a little bit about the algorithm. And just so you know, all of these names of algorithms, I'm just making them up. So like I called it a binning algorithm and a find algorithm. Those aren't real things. I'm just making them up. And this is also, I just made this up, window interpolating algorithm. So it's like finding the window. So just like if you're trying to Google like more information, it might not exist. So we're going to think about this for an example of X, which is data collected on the number of texts a person sent and received per month. And then Y is their age. So pretend that I talked to a bunch of people and I asked them what their age was and how many texts they sent and received. So for example, for ages, I have a 19-year-old, 75-year-old, 66, 35, 16, 27, 49. For the number of texts, the 19-year-old sent 2,000 about, 75-year-old sent 100, etc. Now this is kind of like a groundbreaking problem that like everyone is trying to figure out, so you're really lucky that I'm showing you this right now. Is like, how would you predict someone's age based off of the number of texts they sent? This is how. First, you would need some data on ages and texts, which I just gave you. And this is actually research-based. I actually looked up the average texts sent for different age groups, and then I put this down. So this isn't just completely made up. I fall around the range of the 75 and up for my texts, but I'm just outside the norm, you know what I mean? So let's say that we had X star data, and X star data is, I collected now just some text data, so 151, that could be mine. I'm wondering what would my age be predicted as based off of my text set. But there's a lot of them, like I just collected them from 5 people. And I want to predict the ages of these people based off of the number of texts that they sent. So this is exactly what you're doing in the lab, but you're doing it for solar radiation data and time. That's your X and Y. So let's just talk about what we would need to be able to do to write this algorithm. The first thing is we're writing the algorithm to do the interpolation. So the first thing is you would need to receive the X and the Y, as well as the X star. So these would need to be inputs to the function. So you need to start by having that in the function in order to write the algorithm. Now, if you were going to try to find, like, for example, 151, you wanted to see where that fit in the X array, what would be convenient if the X array was, you know, a certain way. Like right now it's all out of order. So what might we want to do? Yeah, we want to sort x. And you can just use the intrinsic function. You don't have to write a sorting function because it's actually really tricky. And I used to have students do that and I stopped. And a sorting algorithm is going to sort the x values, but you also want to sort the y values the same way that the x was sorted. So you want to keep track of how it reordered x and reorder y in the same way. And so the intrinsic is okay. All right, now you just want to go through and start with your first x star, so 151. And the first step is you need to find the window where x star fits in. So I'm going to say find window where there is a value that is less than it and a value that is greater than it on either neighboring sides. So we've done lots of find commands. What do we do for find commands? What sort of structures do we need to do a find command? A loop and an if statement. You could also do this with a while loop if you want to. That is also possible. But you need to create some sort of find function, which we've already done, so you should have a good idea of that. And then once you find its location, you want to predict the y star value using the formula that we just derived using similar triangles. And so that would be this formula here, that y star equals y1 that function there. You're just gonna, that's what will basically be in the if statement. You can do this a couple ways. You could like define variables x1, y1, x2, y2, and then just call those variables here. Or you can just index properly and use i's and I plus ones. So people do it both ways. So that got us the first y star value. And so this is just going to be just a definition. So, and it will be indexed. You need to make sure you index y star. But there's nothing really particular for that, the MATLAB version. So then you basically need to repeat step 3 for all of your x star values. And anytime you see the word repeat, that should make you think loop, for loop, usually for loop, or a while loop. You can do either, but a for loop, because we do know how many times we're going to run it. We're going to run it for however big x star is. And then the last step is report back what y star is. So that's just by providing the function with y star as the output. So this is the general algorithm that you're going to write, but you're going to have to think about how you're going to structure this, because this is just the algorithm steps, but you got to have to for loop. It's going to be nested inside. There's going to be another for loop nested inside with an if statement. So your job now is to start writing out how you might combine these all. Are there any questions on this before I move on? Yeah. Yes. question?
Are you just finding the slope of it? For the x, y situation?
I already did that. This equation takes care of that. So we already derived the equation, which is the slope comes in right here as y2 over y1 over x2 minus x1. That's where the slope is in the equation. So if you want to redo it some other way, you can, but it's not necessary. Okay, so as an example, let's say that you were trying to find that first x star value of 151. So we know that that's how many texts someone has. Let's think about if we can just do the algorithm ourselves. How old would that person be? So we're going to go back to this data, and this is not sorted, so I'm going to have to kind of sort it by eye. And I need to find the two x values that bracket that. So the two values are going to be 100 and 421. If you just look at your data, those are the two that surround it. It's easier if the array is actually sorted. So we're going to basically grab those correct x1, x2, y1, y2 values. So this is what the x1 value will be. The x2 value is 100. I guess I sorted these in the opposite order, but it doesn't matter. So if you wanted to calculate how old this would predict this person, you would just plug those values into the formula that we wrote. And this is something that you could also write a function that just defines this formula if you want. You could call that function inside the if statement. That would kind of make things a little bit cleaner in your code by just giving it the right x1, x2, y1, y2 values. So we're just going to plug in all the values. And then when you do the calculation, it shows that y star would be 73.57. So that would be how old the person would be predicted based off of the number of texts that they sent, which I'm pretty sure at some point I put that in there because that was the number that I did, my texts. I'm not that old, by the way. I mean, not 75, but like, I should be more into texts based off of just when they were introduced in my life. Just really bad at them. So, okay. You're like, we don't care. Okay. But the last thing I wanted to talk about is this idea of interpolation versus extrapolation, because it comes up in the algorithm. This has also come up a couple times on like quizzes or exams where we've done something similar and people are like, well, what do you do with the bounds? And so while I set up the lab so that there's no problems, it does come up in some of the other things that we do. So let's say that again, you had your data as the points. Interpolation means that the data point that you are trying to predict is between the bounds of the data. So that's what interpolation means. And then extrapolated means that the point is outside of the original data. So it falls on the other end on one of the ends of the bounds. They're both algorithms, but when we talk about interpolation, we're going to require that the data that you're interpolating to falls within the bounds of the data. So extrapolation usually requires you to predict based off of several points on the right-hand side. You can either do linear extrapolation or you can do quadratic extrapolation. And it's important, but not what we're doing. And so you are not going to be extrapolating. Your code should not have to extrapolate anything in any quiz or any or for quiz 9 or for lab 9. And the same thing goes with interpolation as far as higher order goes, we are only covering first order interpolation, which means we're just using 1 point. So linear interpolation is first order and only needs 2 points to predict. But if you want to do higher order interpolation, you certainly can. And depending on the data and how fine your data is, you might need to do that. So this quadratic would be second order, and you would need to use a quadratic function to predict, and it would be using 3 points. So I believe that in 303 you do higher order interpolation, not even using just polynomials, but using some more sophisticated functions. So we are just writing the very, very most basic interpolation function with our linear interpolation function. Is there any questions? Okay, thank you.